Okay, Assalamualaikum warahmatullahi wabarakatuh and very good afternoon. Okay, saya harap semua um, sedang bercuti selamat bercuti. Okay, cikgu buat recording untuk yang mana yang belum masuk kelas. Alright, cikgu hari tu dah buat beberapa nota lah habiskan arithmetic dengan geometric progression. So untuk yang belum hadir ke kelas, yang belum berjumpa bersemuka dengan cikgu, cikgu ingin buat recording ni lah for you guys. Tolong rujuklah recording ni supaya kita semua nanti bila bersemuka naik cuti di Pabali ni, kita semua dah tak ada penggiliran semua dah bersemuka. So kita berada di page yang sama lah Alright, so since none of you are attending the class for this afternoon, so please feel free to refer to this recording, right? And if kalau ada yang tiba-tiba muncul, selamat datanglah ke kelas cikgu untuk hari ini. Alright, so let's begin our lesson. Alright, now what we have here, right, is some more questions lah. I like to share with you what I did with the class yesterday. Okay, so we've done a few questions regarding geometric progression and also sum to infinity for geometric progression. And we ended up until I think only one example, one or two examples for sum to infinity. Right. So the question is, right, the second, fourth, and eighth term of an arithmetic progression are the first three terms of a geometric progression. Find the common ratio of the geometric progression. Right. I think we haven't done this yet. Cikgu dah buat dengan kawan-kawan yang berada di kelas lah hari Rabu itu. Okay, so for question number 9, for kata sini, the second, fourth and eighth term, term kedua, keempat dan ke-8, right? So second term, let's say our first term, okay, normally first term we put it as A, right? Second term will be A plus D, alright. Fourth term, alright, will be A plus N minus 1 Dn, kata kepada the number N here, right? So this is equals to A plus 3D, right? The eighth term is just A plus 7D, okay? Right, welcome Michelle, right? So for Michelle, all right, okay, alright, ramai yang join okay, cikgu buat recording kok ada kawan yang tak boleh nak join, right? So cikgu ada buat recording lah, so cikgu ulang balik lah right. We will discuss about question number 9 question number 9. Question number 9 goes as the second, fourth, and eighth terms of an arithmetic progression are the first three terms of a geometric progression. Okay, find the common ratio of the geometric progression. Okay, so that you need to find the relationship between arithmetic progression and geometric progression, okay, to solve this. So the first thing I did was I introduced terms. So you need to know for the first term, okay, normally first term, we will write it as A. Second term will be A plus D, and then and so on. And so the fourth term will depend on A plus N minus 1 D, right? So if N is 4, then 4 minus 1 D. So here becomes A plus 3D. For the eighth term will be A plus 7D. Okay. So now what is the relationship between arithmetic progression and geometric progression? Um, you can relate them using the geometric mean, okay, or arithmetic mean. So in this case, the question asks for common ratio of the geometric progression. So we have to relate with the geometric mean. Okay, so geometric mean is given by b equals to square root AC, right? So this you already know, all right, from the notes and also from your assignment. Daripada assignment pun kita dah tahu geometric mean is b equals to square root AC. So you can rewrite this to become b square equals to AC, right? So if we let the second term to be A, the fourth term to be B, and the eighth term to be C, right? So we can substitute in, okay, these terms into the geometric mean, right? So let's try to do this. So this is A plus 3D square equals to A plus D multiply with A plus 7D, right? So this is, if we expand this is A square plus 6AD plus 9D square equals to A square plus 8AD plus 7D square. Okay, okay. So we have here these two A square can cancel. So we have 9D square minus 7D square plus 6AD minus 8AD equals 0. So you have 2D square plus minus 2AD equals to 0, right? So then now we can factorize, okay, 2D D minus A equals to 0. Okay, so you have 2D equals to 0 and D minus A equals to 0. So D equals to 0 and D equals to A. So now for a progression, okay, since this is a progression, hence D cannot be 0, right? D cannot be 0 because it's a progression. They mesti start with A and then A plus D. Okay? D cannot be 0. If D equals to 0, then this term here is A. So dia tak ada progression. Okay? At least D must be equals to a number lah, 1 ke, 2 ke, 3 ke, 4 ke, something. It cannot be 0. Alright? Because it's a progression, dia mesti meningkat. Okay, meningkat naik. Right? So this hence D cannot be 0. Therefore, right, D equals to 0 is rejected. Okay, we reject D equals to 0 because this is a progression, progression. So D cannot be 0. Okay, so let's look at D when D equals to A. So R is just the second term divided by the first term. So you have A plus 3D divided by A plus D. Right? So since D equals to A, so you have 4A divided by 2A. So R equals to 2. Okay. Right? Okay, ada soalan tak? Okay, R equals to 2. Jika series boleh semua nombor sama, tak boleh. Dia tak boleh nombor yang sama lah. Dia tak jadi bukan series lah, progression progression. Progression cannot have the same number. Right? Kalau tak dia tak jadi progression lah. Progression dia mesti meningkat ataupun menurun. Menurun. Kalau tak namalah progression. Dia tak boleh nombor yang sama lah. D tu mesti ada. Yang 6, 6, 6, 6 tu tak kira lah. Dia bukan janjang lah. Dia bukan janjang. Dia constant. Constant lah. 6. Sebab dia D sama dengan 0 kan. Dia bukan janjang lah. Right? Semua number yang sama. Common difference cannot be 0. Cik tengok nota je. Dia kata sini. Ni ya. Keshan tengok sini dia kata dalam nota ni, hence the general term is given by Tn equals to A plus N minus 1 D. D equals to Tn minus 1. D must be a constant. D cannot be zero. Pada dalam notes. D cannot be zero. And D must be independent of N. Okay, dia adalah constant. Dia tak boleh ada N lah dalam D. Dia adalah constant, some number lah. And that number cannot be zero.
Oh, cikgu. So dalam itu manual math T dia ada set 19 then repeat 4 kali. Dia dikira set of number saja, tak kira dia jenjang apa lah.
Bukan, dia bukan apa-apa janjang lah. Dia just set of numbers lah. Dan kamu tak boleh kira benda tu sebagai arithmetic ataupun geometric progression lah. Dia bukan salah satu lah. Tapi you still can find the mean kan. Boleh cari mean dia. Tapi mean dia adalah nombor yang sama lah kan. Untuk assignment tu. Cumanya dia bukan bawah arithmetic series ataupun dia bukan bawah geometric series. Okay. Kalau ada soalan tanya je nanti kita cuba selesaikan kalau sempat kita selesaikan, kita cuba selesaikan. Alright, so you have to make sure D is a constant, it cannot be zero, it also must be independent of N, independent of N. Alright, let's look at this question here. Okay, question number 10. The nth term of an arithmetic progression is Tn. Show that Un equals to 5 over 2 minus 2 to the power of 2 multiplied with 10 minus Tn over 17 is the nth term of a geometric progression. Okay. So they not show that this is a geometric progression. Un is geometric progression. So to show geometric progression, kita pernah bincang lah untuk show geometric progression, we have to do Un over Un minus 1. Ni banyak kali lah kita dah buat. Right? Okay, so to show GP or AP, what you need to do is to show that Un over Un minus 1, right, equals to constant. Or you can have Un plus 1 over Un equals to constant. All right, either these two lah. Right, you show Un over Un minus 1 or Un plus 1 over Un is a constant. So in this case, you have Un equals to 5 over 2 minus 2 to the power of 2 multiply with 10 minus Tn over 17, right? So if we use this one, okay, so Un minus 1 is just 5 over 2 minus 2 to the power of 2, 10 minus Tn minus 1 over 17, right? The difference is just for Tn and Tn minus 1. So what we need to do is to divide these two. Okay, so for Un divided by Un minus 1 is just 5 over 2 minus 2, 2, 10 minus Tn over 17, right, over 5 over 2 minus 2 square, 10 minus tn minus 1 over 17, right? Okay, so now these two can cancel, right? But this you cannot just simply cancel because you have different uh, term. For here you have tn, here you have tn minus 1. So this is just, all right, equals to minus 2 to the power of 2. And since the base is the same, so this is just uh, 10 minus tn over 17, all right, minus, all right, 2, 10 minus tn minus 1 over 17. Okay, so let's factorize 2 over 17. 2 over 17, right? So we have here 10 minus tn minus 10 plus tn minus 1. Okay, so here you can cancel the 10. So you have here minus 2, 2 over 17 minus tn plus tn minus 1. Right. So you know from the notes that d equals to tn minus tn minus 1. Okay, or d is tn plus 1 minus tn, right? So for this case, right, if we substitute out or we factorize out the minus sign, okay, minus 2 over 17, you get this is tn minus tn minus 1, right? So this is same as d, right? So you can substitute this as minus 2 over 17 d. Okay? And you know that d, okay, d is a constant, right? This is a constant, okay, constant. Right? So since this is a constant, this is a constant, this is constant, this is constant, so this is all constant. Okay. Minus 2 is a constant. Power of minus 2 over 17 is a constant. D is a constant. Now everything is a constant. There's no or no reliable of the value of n, all right, term of n. So it's independent of the term n, thus it's all constant. Right? Now you can conclude that since, okay, un over un minus 1 is a constant, hence this is a geometric progression. Okay, just showing that it is a constant, you can get to prove that this un is a geometric progression. Okay, boleh eh? Now, if Tn equals to half 17n minus 14, evaluate, okay, 1 until 10. Tapi kalau kita nak buat 1 to 10, tak ada masalah lah. Terus buat 1 to 10 je lah. So, evaluate from 1 to 10. So sum 1 to 10 for un. Okay. So you know that un is okay, so this is sum 1 to 10 for 5 over 2 minus 2 to the power of 2. 10 minus, now Tn is given as half 17n minus 14. Okay, so this is half 17n minus 14 over 17. Okay. So let's okay, now let's try to substitute in value of n, right, when n equals to 1. So sum. Selalunya kita buat sum macam mana? Masuk je lah nilai kan. So you have 5 over 2 minus 2 square, 10 minus half, 17 minus 14 over 17. Right? So ni dapat apa? Tak. Ada seorang boleh kira tak? Ni sus. So ni adalah 3 per 2. 3 per 2. Sekejap cikgu ambil calculator sekejap. So dia adalah 2 kedua dah. Not a number. Tiga puluh. Minus 5. T1. So this is equals to A. E10 equals to 5 over 2 minus 2 square. 17 times 10 is 17. So this is 17 minus 15. Two. Seven. Six. So this is L. So sum equals to E plus L E plus N divided by geometry progression. Oh, okay. Alah. Second term. R equals to UN over UN. Minus 2. Okay. Un minus 1 is this. Minus 2. 2 over 17. And pounds. 17. So 17 over 2n minus 17 over 2n. 7 minus 7. Yang tinggal hanya 17 over 2. 7 minus 2. Minus 2 over 17 minus 17. So minus 2 to the power of minus 1. Minus 2 to the power of minus 1 is just half. Okay, so S tan lah kan? Tan kan? Dan Sn equals to A 1 minus Rn over 1 minus R. So this is S10 equals to A is minus 5, 1 minus R is minus half, and S10 divided by 1 minus. Cuba kira ini. So minus half to the power of 10 1 minus okay times minus 5 divide by so this is equal to minus 3.10. Okay, dapat Alright. Dekat kelas cikgu buat sum to infinity sebab dekat dalam soalan dia tak buat sum to 10, dia buat sum to infinity. Tapi benda yang samalah. Benda saya kalau sum to infinity sum to infinity, you still have to find a, and then 1 minus r. Okay, r is into lah. Okay, so sum to infinity is just minus 5 divided by 1 minus half. Okay, so it's equals to okay, minus 5 divided by 1 plus 1. Same. Sama lah juga. Okay. Minus 3.33 juga. Okay. Right. Let's move on. Cikgu tak nak ambil masa lama sangat lah. Yalah, ini kamu boleh buat sendiri. Okay, cikgu akan bagilah latihan. Cikgu nak share. Okay, sum to infinity. Sum to infinity. Right. Sum to infinity, right, is given here as n tends to infinity becomes large, r to the power of n tends to become 0. So r to the power of n equals to 0. Hence, sum to infinity is just a over 1 minus r. Okay, this is true when r is less than 1. When modulus r is less than 1. If modulus r is bigger than 1, then the sum to infinity never exists. Okay, because when r is bigger than 1, okay, r to the power of n diverges to infinity. Dia jadi besar lah. So sum to infinity does not exist. So you have to know these two conditions. For S infinity to exist for a given geometric series, the common ratio of the geometric series must satisfy this condition, where R is in between minus 1 and 1, and R cannot be 0. R cannot be 0. And then there is another equation that you need to know of. Okay, if S infinity exists, then Sn, okay, Sn is equal to 1 minus r to the power of n multiplied with S infinity. Later we'll look at one example that relates between Sn and S infinity. Okay, let's look at one example here. Okay, find the set of values of P if the sum to infinity of the series exists. Hence, determine the value of S infinity in terms of P. Right. So you have 1 plus 1 minus P over P plus 1 minus P square over P plus that. Okay, and the sum to infinity exists, right? So right now, let us try to find R and P. R and A equals to 1. R is just 1 minus P over P divided by 1. So R is 1 minus P over P. Oh, okay. Right. Since S infinity exists, okay, then R, oh, sorry. R must satisfy these conditions. Right? Modulus R is less than 1 and R cannot be 0. Okay, so we have to test for R, right? So 1 minus P over P must be in between minus 1 and 1. And R or 1 minus P over P cannot be 0. Right? So let's look at this part here first. So 1 minus P over P is bigger than minus 1. 1 minus P over P is less than 1. Right? So 1 minus P over P, right, plus 1 is bigger than 0. Here you have 1 minus P over P minus 1 is less than 0. So you have 1 minus P plus P over P is bigger than 0. Here you have 1 minus P minus P over P is less than 0. So these two cancel. You have 1 over P is bigger than 0. P is bigger than 0. Okay. Here you have 1 minus 2P over P is less than 0. So for this case here, if you multiply P, right, for the denominator and numerator, you get P minus 2P square over P square is less than 0. So you get P minus 2P square is less than 0. So P 1 minus 2P is less than 0. You factorize here, you get P 1 minus P, 2P is less than 0. So P equals to 0 and 1 minus 2P equals to 0. Right? So P equals to half. Since this is A is negative, so you have this N shape. Okay, one is 0, one is half. And you want less than, less than. So less than 0 is this region here and this region here. So we have here, you can say that P ada atas meja. Jumpa. Kita buat balik tak? Okay, thank you. Alright, so P is less than 0. And or union union or P is bigger than, right? Right. But here you have this condition P is bigger than 0. Right? And, right? And or. So we make a number line, right? Number line. Number line. So now 0 and then half. So now P is bigger than 0. P is bigger than 0. Then we have P is less than 0, recording there. Then P is bigger than half. That is bigger condition. P bigger than 0, P less than 0, and P bigger than half. So kita sekarang ni, dia ni dua ni OR, tapi dengan ni AND. Okay, AND. So mana AND? Mana AND? AND is the one that kita kata bertindih lah, bertindih. Or overlap, overlap. Which one does overlap the other? So we can see here that these two overlap each other, and hence we can say that P is bigger than half. Right? It's bigger than half. Okay. This is the first condition. First condition. Second condition is when 1 minus P over P is not equal to 0. So 1 minus P is not equal to 0. P is not equal to 1. Ada meeting condition juga. So in the end, you can also state that P is bigger than half. P is not equal to 1. Right. That is your answer. Boleh faham? Ada soalan tak? Okay. There is another example, okay, involving exponentials, where for exponentials, it's a bit different, a bit different for exponential compared to other functions. Okay? So I'll show you one example using exponential, involving exponentials. All right, this question here. Okay, determine the set of values of x such that the geometric series e to the minus x, e to the minus 2x, and e to the minus 3x converges. Okay, find the exact value of x if the sum to infinity of the series is 3. Okay, it's 3. So meaning that the sum to infinity exists. Okay, if the sum to infinity exists, so what is the value of x? What is the value of x? Okay, set of values of x converges. Converges. Apa maksud soalan ni? Alright, daripada sini lah, determine the set of values of x such that the geometric series given here dia tak ada akhir. Dia ada dot dot dot, dia tak ada nombor akhir. Dia tak ada tn, dia tak ada tn lah, the last term tak ada. So ini kena hati-hati lah. Soalan macam ni kalau kamu nampak, the start e to the minus x and then the dot dot dot, and then say converges. Okay, converges means that at the end, dekat infinity, infinity they converge to one number. So S infinity exists for this case, right? So you need to find the value of x for S infinity converges. Right, so you have e to the minus x plus e to the minus 2x plus e to the minus 3x plus dot dot dot, right? And you kata converges, right? This means that to infinity exists, S infinity exists, right? For S infinity exists, you have two conditions. Modulus of R is less than 1 and R is not equal to 0. So you know that A is e to the minus x, R is just e to the minus 2x divided by e to the minus x. So this is equals to e to the minus x. So we have to test for R. So this is e to the minus x is between 1 and minus 1, right? So here comes the part where the exponential function is special, right? Another condition is e to the minus x cannot be 0, right? So if you look at the exponential graph, okay, the exponential graph starts from minus infinity and then goes up, right? And it intersect at 1, right? Is for e to the x. For e to the minus x, it's just the reflection about the y-axis, right? So this e minus x. So you can see here that there are no values below 0, all right? So values of minus 1, okay, does not exist. It does not exist. So for exponents, okay, exponential function, e to the minus x must be less than 1 and bigger than 0, okay, because it just touches 0, okay? It does not go to 0. So e to the minus x cannot be 0 is true. Uh, is is true. Okay, true. Because e to the minus x does not touch 0. Okay, it cannot be 0. Right? Because 0 is an asymptote. Okay, is an asymptote. Right? So we only have to test for e to the minus x in between 0 and 1. Okay. So e to the minus x is bigger than 0. E to the minus x is less than 1. Since e to the minus x is bigger than 0, right? So this is applying to all values of x. Okay, hence this is x all values, right? From minus infinity to infinity, okay, it's bigger than 0, above 0. But for e to the minus x less than 1, okay, less than 1, so this is e to the minus x less than e to the 0. E to the 0 is 1. So since base is the same, so minus x equals to 0. Oh no, that's not 0. The inequality less than 0. So x is bigger than 0. Okay. Since these two end, okay, end, so we have two condition, okay, 0 and all real number, x bigger than 0 and all real numbers. Okay. So n means which overlap, overlap these two. So here you can say that uh, x is bigger than 0 and x cannot be 0. Right. These are the conditions for x, x for sum to infinity to exist. Right. If the sum to infinity is equals to 3, right? So you have here a is a over 1 minus r equals to 3 lah, right? So a is e to the minus x divided by 1 minus e to the minus x equals to, so e to the minus x equals to 3 minus 3 e to the minus x. E to the minus x by plus 3 e to the minus x equals to 3. E to the minus x 1 plus 3 equals to 3. E to the minus x equals to 3 over 4. Okay, so you can put ln e to the minus x equals to ln 3 over 4 minus x, okay, equals to ln 3 over 4. X equals to ln 4 over 3. Okay, any questions for ln? For ln, for value of x. Ada soalan tak? Okay, kalau ada soalan, cikgu ada lagi dua example untuk tunjuk dan kita habis dekat situ lain, dua example ni. Sebab dekat kelas pun cikgu sampai example yang ke-10, right? Let's look at another example. This example here. All right, the first three terms of a geometric progression are 2 minus half and 1 over 8. Find the smallest value of n such that the difference between the sum to infinity and sum to the first n terms is less than 10 to the minus 5. All right, so ni kamu kena tahu whenever you find different of sum, okay, different of sum, kamu kena guna modulus S infinity minus Sn. Okay, S infinity kat depan, because infinity ni besar, right? Benda yang besar tolak benda yang kecil, right? So S infinity minus Sn is your different of sum. Okay, dan mesti ada modulus. Okay, mesti ada modulus. This modulus is so that bila jawapan S infinity mesti positif. Okay, mesti positif. Alright, so we have here our sequence is 2 minus half and 1 over 8. So A equals to 2, R equals to minus half divided by 2, which is minus 1 over 4. Right? So a difference in sum is modulus S infinity minus Sn less than 10 to the minus 5. Okay. So now we have to find S infinity. S infinity is A over 1 minus R, which is 2 over 1 minus 1 over 4. So this is equals to 8 over 5. What is Sn? Okay, Sn is given by the formula that I've mentioned earlier, which is 1 minus r to the power of n multiplied with s infinity. So this is a very useful formula to find different of sum. Okay, different. Kalau kamu tak tahu ini, kamu akan susah lah. Because the easiest formula to form is S infinity. So dia perlukan A, the first term, and the ratio, right? But for Sn, okay, Sn is just 1 minus Rn multiply with the sum to infinity. So this is just 1 minus 1 over 4 to the power of n multiply with 8 over 5. So here you have sum to infinity, okay, modulus 8 over 5 minus 8 over 5, 1 minus 1 over 4, n, right, less than 10 to the minus 5. Okay. So this is just 8 over 5 minus 8 over 5 plus 8 over 5 is 1 over 4 in less than 10 to the minus 5. Okay, these two can cancel. So you are left with um, um, 8 over 5 is 1 over 4 n less than 10 to the minus 5. Okay, so can bring this to the right hand side. So this becomes 1 over 4 n is less than 6.25 times 10 to the minus 6. Okay, now your modulus has gone, so this becomes a positive value, right? If this is still a negative value, if you do not put a modulus sign, if this is a negative value, then you will get your answer wrong, right? Because n, if this is negative, then you will get less than, dia tak bertukar simbol nanti, right? So ln, you can ln both sides. So ln 4n ln 6.2 6. So this is n for positive 1 over 4. So this will give you negative 1.386, which is less than negative 11.98. So n is bigger than 8.644. Hence, you can see that the smallest value of n is equals to 9. Right? So this is the use of Sn equals to 1 over Rn multiplied with S infinity. And also for difference in sum, right, you have to put a modulus sign. If you do not put a modulus sign, then this will become wrong, right? Bila negative, sini negative. So jadi positive, you cannot change this symbol to be bigger than, right? It jadi less than. Okay, ada soalan? Okay, kalau tak ada satu, yes. Yes, Kishore. Itu soalan nak salin dalam kertas ke? Soalan apa yang pernah bincang salin dalam soalan dalam kertas. Terpulang pada kamu lah, terpulang pada kamu. Kalau kamu rasa kamu nak salin, okay. Ni antara contoh-contoh soalan yang boleh keluar lah. Examples lah, examples. Kita bincangkan examples ni. Kalau kamu nak salin, salin. Kalau tak nak, ambil gambar lah. Kamu ambil gambar, alright, you take picture, and then baru you salin balik lah. Right? Kalau tak sempat nak salin, ambil gambar. Okay, one last example. Alright, here. Right, write the infinite recurring decimal. Infinite recurring decimal. 0.1318. There's a dot. The dot di atas 1 and 8. So this is equal to a recurring decimal of 1 and 8. Okay, you can see here 0.13181818 and so on. Right? As the sum of common geometric series. Hence, express the recurring decimal as a fraction. A fraction in its lowest term. Okay, so dia minta kita buat dalam bentuk fraction, in terms of fraction. Okay, last example for today. Okay, so you have 0.1318 and then there's dot on top of 1 and 8. So this is equals to 0.1318181818 and so on. Right? If you have 0.1318 and there's 3 dots, okay, 3 dots. So this is equals to 0.1318, 318, 318, 318. So, okay, so it depends on where the dots are lah. So that is where the recurring occurs. So if there's only 2 dots, then the recurring happens to 2 numbers. If the dots are on all 4, all right, example here, for example, if you have the recurrence of all 4 numbers, dot, semua ada dot, okay, semua ada dot atas. So this is just 0.131813181318. Okay, so depending on where the dots are lah. Okay. Kalau dots dia dekat last je, 0.131, and then there's only 1 dot. Okay, so this is just recurrence of 8. 0.131, 8, 8, 8, 8, 8, 8, and so on. Okay. So tu antara contoh-contoh dots yang boleh ada lah until infinity. So what can we do? Okay, to find the sum to infinity. Sum to infinity. Okay, what we know is sum to infinity. We have to find a geometric progression. Geometric progression for GP. So in this case, where is the GP? Right? Where is the GP? The GP here, okay, is for 0.1318. So ada dua dot So this is 0.13 plus, okay, 0.0018 plus 0.00018 plus 0.00000018, okay, and so on. Plus dot dot dot. Okay. Mesti ada dot 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 ni lah, right? So untuk jawapan for your working must have at least 3 terms, right? For GP. Right, mesti ada 3 terms. First term, second term, third term. And then ni pun mesti ada dots must show, right? So this is not considered as a term, okay, not a term, right? Because the GP only starts at 1, 8, 1, 8, and so on. So A is 0.0018 and then R is 0.000018 divided by 0.0018. So this is 0.01. Okay, 0.01. So sum to infinity is just A over 1 minus R, which is 0.0018 divided by 1 minus 0.01. So this is equal to 18 over 9900. Okay, so this must be in fraction. Okay, so dia minta kita jawapan dalam fraction. So right, ni adalah S infinity for GP tu, right? So for the whole, for hence for 0.1318 is equals to 13 over 100 plus 18 over 9900. Okay. Ni kira masuk juga lah sebab dia ada 1318 kan. Okay. So this is equal to 29 over 220. Okay. So it must be in fraction. Okay, ada soalan tak? Alright, kalau tak ada soalan, cikgu stop kat sini dulu. Okay, thank you for attending today's class. So cikgu harapnya nanti bila kita naik cuti Deepavali nanti, alright, kita dah sama satu page lah, the same page. Okay, so cikgu harap tak ada yang tertinggal lah. Kalau yang tak hadir untuk kelas hari ni, tolong tengok pada recording ni yang nanti cikgu share. Pastikan kamu dapatlah apa yang cikgu tunjuk hari ni. Alright, thank you for all of you who attend today's class. I'll see you bersemuka nanti, alright, on the 8th. 8th. Alright, okay, see you, bye-bye. Stop.